projects. In this video, we are going to explain about the project title, a fast, accurate deep learning framework for prediction of all cancer types. Before diving into the execution, let me give you an overview of the project. Cancer is when cells grow out of control, damaging healthy tissues and organs. It can start from various factors like genetics, environmental exposures like smoking, and lifestyle habits like diet. These rogue cells can spread to other parts of the body if not stopped. Early detection and accurate prediction are crucial because they allow doctors to intervene sooner with right treatments, improving the chances of survival. This project aims to predict various cancer types, including lung, prostate, cervical, and colon cancer. Lung cancer, which starts in the lungs, is often associated with smoking but can also affect non smokers with two primary types: non small cell and small cell cancer lung. Prostate cancer develops in the prostate gland and is common among men. Cervical cancer forms in the cervix due to HPV infection and can be prevented through vaccination and regular screenings. Colon cancer affecting the colon or rectum usually stems from precancerous polyps, underscoring the importance of early detection through screening for effective treatment. Traditional cancer prediction methods, including imaging, biopsies, and blood tests, face challenges such as subjective interpretation, invasiveness, and limited accuracy. These limitations highlight the need for more precise and less invasive prediction approaches to enhance early detection and improve patient care. The proposed system utilizes LSTM, long short term memory, and CNN, convolutional neural network, deep learning algorithms to create accurate cancer prediction models. Diverse data sets tailored to lung, prostate, cervical, and colon cancer types enhance prediction accuracy by incorporating medical imaging scans, patient records, and clinical data for training and validation. The project benefits patients by accurately predicting cancer early, which enables timely treatment and improves outcomes. Healthcare providers gain access to precise prediction models, aiding in treatment decisions. Researchers benefit from advancements in cancer biology and diagnostic tools, aiding ongoing efforts to understand and combat cancer. Integrating Flask facilitates the development of a user friendly web interface to access the cancer prediction models. This enables users to input data and receive predictions for various cancer types, improving accessibility and usability. To implement this project, we need software and hardware requirements. Software requirements of the project are: application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements of the project are: operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Algorithms used: these are the algorithms built in the project, which are long short term memory and CNN, convolutional neural network, for predicting all cancer types. Now let us execute the project. To execute this project, first we need to open the code folder, which contains the project source code files. So here, this is the colon images sets folder. In this folder, we have the images for the colon cancer. So here we have the colon ACA images. So these are colon adenocarcinoma images. And here in this folder, we have the colon N images. So these are the images for the colon cancer. And here, this is the output folder. In this, the data set is split into training and validation. In the training folder, we are again having two folders named as colon ACA and colon N. In the colon ACA folder, we have the colon adenocarcinoma images. And all these images are used to train the model. And here in the :n folder, we have the :n images. So these images are used to train the model. Similarly, in the validation folder also, we have the two folders named as :ACA and :n. And in each of the folder, we have the images for the respective colon cancer. And all these images present in the validation folder are used to evaluate the performance of the model. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here, this is the breast cancer Wisconsin dataset. Let us open this. So here we can see the different features: ID, clump thickness, uniform cell size, uniform cell shape, mark addition, epithelial, and other features. So this is the data set for the breast cancer Wisconsin. Let us close this. And here these are the model files which contain algorithm information which will be loaded into the project code during runtime. And here this is notebook.ipynb file. This is the Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And here this is the prostate cancer dataset. Let us open this. So here we can see the different features: ID, diagnosis result, radius, texture, perimeter, area, smoothness, compactness, symmetry, and fractal dimension. So we will use this data set during the execution. Now let us close this data set. And here this is signup.db file. This file is the database file used to store user information. And here we have the SOBER 72 dataset. That is the cervical cancer data set. So here we can see the different parameters, which are behavior, sexual risk, behavior, eating, behavior, personal hygiene, intention aggregation, intention commitment, attitude consistency, attitude spontaneity, norm significant person, norm fulfillment, perception vulnerability, perception severity, motivation strength, motivation willingness, social support emotionality, social support appreciation, social support instrumental, empowerment knowledge, and empowerment abilities, empowerment desires. And here this is the target column in which we are having two labels, 1 and 0. 1 means cervical cancer is detected, 0 means cervical cancer is not detected. Now let us close the data set. So first we need to copy the path of the code folder from the address bar of the file explorer. So here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are new users, we need to register first. So click on sign up link here. So here we need to enter all these details to register. But I have already registered. So click on sign in button. So here we need to enter the username and the password, which are static, and then click on submit button. We are redirected to the prediction page. So here we can see different links. One is for lung cancer, prostate cancer, cervical cancer, and colon cancer. So first we will do the prediction for the lung cancer. So click on it. So here we can see the different parameters. So here we need to enter the values of these parameter, and after entering the values, the application will predict whether lung cancer is detected or not. Before entering the parameters, let us understand the parameters. So the first one is gender, whether it is male or female, and the second one is age. We need to enter the age of the person. Third is smoking. We need to see whether the person smokes or not. Coming to the next parameter, which is yellow fingers. Nicotine staining of fingers, anxiety, mental condition with worry and fear, peer pressure, influence from social circle, chronic disease, long term medical condition, fatigue, feeling tired or lacking energy, allergy, immune response to harmless substances, wheezing, high pitched breathing sound, alcohol consuming, drinking alcoholic beverages, coughing, reflex to clear throat or airway, shortness of breath, difficulty breathing sufficiently, swallowing difficulty, trouble swallowing food or liquid, chest pain, discomfort or pain in the chest. So here we need to enter these values from the test cases. So here I have entered all the parameters value from the test cases. So here the gender is 1, it means it is a male, age is 69, smoking 1, it means that the person smokes. Here 1 is yes and 2 is no. Yellow fingers 2, that means the person is not having yellow fingers. Anxiety 2, it means that the person is not having anxiety. Peer pressure 1, that is yes. Chronic disease 1, it means yes, the person is having peer pressure as well as the chronic disease. Coming to fatigue, it is 2, that is the person is not having fatigue. Allergy is 1, it means that the person is having allergy. Wheezing is 2, alcohol consuming 2, coughing 2, shortness of breath 2, swallowing difficulty 2, chest pain is also 2. It means that the person is not having any of these symptoms, any of these parameters. So I have entered all the values. Now click on submit button. So here we can see the result, that is you are safe. It means that the person is not having lung cancer based on the information which we have provided. Now click on try again. Let us enter another set of parameters. So here I have entered another set of parameters from the test cases. So the gender is 0. It means it is a female. Age is 59. Smoking 1. Means the person smokes. 1 is yes and 2 is no here. So 1 smoking, it means that the person smokes. Yellow finger, anxiety, the person is having yellow fingers as well as anxiety. Peer pressure 2, it means that the person is not having any peer pressure. Chronic disease is 1, it means that the person is having chronic disease. Fatigue 2, allergy 1, wheezing 2, alcohol consuming 1, coughing 2, shortness of breath is also 2, and swallowing difficulty 1, chest pain 2. So the person doesn't have chest pain. So I have entered all the values. Now click on submit button. So here we can see the result, that is you are safe. It means that the person is not having lung cancer based on the information which we have provided. Now click on try again. Let us enter another set of parameters from the test cases. So here, these are the test cases. So from here, I'm entering the parameters value. So here I have entered another set of parameters. Gender is 1, that is male. Age is 55. Smoking 1. Yellow fingers is also 1. Anxiety 1. Peer pressure 1. Chronic disease 1. Fatigue 1. Allergy is also 1. Wheezing, alcohol consuming, coughing, shortness of breath, swallowing difficulty, chest pain. All the values are 1. It means that the person is suffering with all of these. Now click on submit button. So here we can see the result, that is affected with lung cancer. So here the person is having lung cancer based on the information which we have provided. In this way, just by entering the values, we can predict whether the person is suffering with lung cancer or not. We can try with more test cases. Now click on try again. Now let us do the prediction for the breast cancer. So here we have the different parameters related to breast cancer. So here we need to enter these values, and after entering the values, the application will predict whether breast cancer is detected or not, whether it is benign or malignant. So here let us understand the parameters first. So the first one is clump thickness. This refers to the thickness of the clumps of cells present in the sample. Increased clump thickness can indicate a more aggressive tumor. And the next one is uniform cell size. Uniformity in cell size refers to how similar the sizes of the cells are in the sample. Variation from this uniformity can be indicative of abnormal cell growth, which is often a characteristic of cancer. Coming to the next one, which is uniform cell shape. Similar to uniform cell size, this parameter assesses the regularity of cell shapes in the sample. Cancer cells often exhibit irregular shapes compared to normal cells. And the next one is marginal adhesion. This describes how well the tumor cells are sticking together. Lower adhesion can indicate a more aggressive tumor that is more likely to spread. And the next one is epithelial cell size. This parameter evaluates the size of the epithelial cells, which are cells that line the surfaces of tissues and organs. Enlarged epithelial cells can be a sign of abnormal growth. The next one is bare nuclei. This refers to the presence of nuclei without surrounding cytoplasm in the cells. Abnormalities in the number of appearance of bare nuclei can be indicative of cancer. And the next parameter is bland chromatin. Chromatin is the material that makes up chromosomes within the nucleus of a cell. Bland chromatin refers to normal, uniform chromatin patterns. Abnormal chromatin appearance can be associated with cancer. And the next parameter is normal nucleoli. Nucleoli are small structures within the nucleus of a cell that are involved in the production of ribosomes. Abnormalities in nucleoli size or number can be indicative of cancer. And the next one is mitosis. Mitosis is the process of cell division. A higher number of mitotic figures in the sample indicates increased cell proliferation, which is a hallmark of cancer. So these parameters are used collectively in a scoring system to help pathologists evaluate the characteristics of tumor samples. Now let us enter the values from the data set. So here I have entered the values from the test cases. Now click on submit button. So here we can see the result, that is benign detected. So the person is having breast cancer, but it is not dangerous. It will not spread further. Now click on try again. Let us enter another set of parameters from the test cases. So here I have entered the values. The clump thickness is 8, uniform cell size is 7, uniform cell shape is 5, marginal adhesion is 10, epithelial cell size is 7, Bare nuclei is 5, bare nuclei is 9, bland chromatin is 5, normal nucleon is 5, mitosis is 4. Now click on submit button. So here we can see the result, that is malignant detected. So the person is suffering with breast cancer, which is classified as malignant and which must be treated immediately. Now click on try again. In this way, we can enter more test cases and check whether the person is suffering with breast cancer or not. Now let us do the prediction with the prostate cancer. So click on it. So here, these are the different parameters related to prostate cancer. So here we need to enter the values, and after entering the values, the application will predict whether prostate cancer is detected or not. Before entering the values, let us understand the parameters. So here the first one is radius. Radius is the size of tumor within the prostate. The next one is texture, spatial patterns in prostate tissue, perimeter, boundary of abnormal growth, area, total surface occupied by tumor, smoothness, regularity of tumor contours, compactness, density of tumor features, symmetry, balance of prostate features, fractal dimension, complexity of tumor shape. Now let us enter the values from the test cases. So here I have entered the values. Radius is 23, texture is 12, perimeter is 151, area is 954, smoothness is 0.143, compactness is 0.278, symmetry is 0.242, and fractal dimension is 0.079. Now click on predict button. So here we can see the result, that is benign detected. It means that cancerous cell is detected, but it is not dangerous. Now click on try again. Let us enter another set of parameters. Click on prostate cancer here and see whether the person is suffering with the prostate cancer or not. So I'm entering the values. So here these are the values which I have entered from the test cases. So the radius is 20, texture is 14, perimeter is 130, area is 1260, smoothness is 0.098, compactness is 0.103, symmetry 0.158, fractal dimension is 0.054. Now click on predict button. So here we can see the result, that is malignant detected. It means cancerous cell is detected and it is very dangerous, and it is important that the person seeks a doctor immediately. Now click on try again. Now let us do the prediction for the cervical cancer. So click on it. So here we need to enter all these parameters value, and after entering the value, the application will predict whether the person is suffering with cervical cancer or not. Before entering the values, let us understand what the values are. So the first parameter is behavior sexual risk. Actions related to sexual activity that may increase the risk of cervical cancer, such as multiple sexual partners or lack of condom use. And the next parameter is behavior eating. Dietary habits and choices that can impact cervical cancer risk, such as consumption of fruits and vegetables rich in antioxidants or avoidance of processed foods. Behavior personal hygiene, practices related to personal cleanliness and health maintenance that may affect cervical cancer risk, such as proper genital hygiene or regular screening. Coming to the next parameter, which is intention aggregation, the tendency to combine various intentions or goals related to cervical cancer prevention or screening into a unified plan of action. Intention commitment, the level of determination or dedication to carry out intentions or plan regarding cervical cancer prevention, such as scheduling regular screenings or getting vaccinated against HPV. And the next one is attitude consistency, The degree of alignment between beliefs, values, and attitudes toward cervical cancer prevention and screening behavior. Attitude spontaneity, the natural inclination or readiness to engage in cervical cancer prevention behaviors without external influence or caution. Norm significant person, the influence of important individuals in one's life, such as family members, friends, or healthcare providers, on cervical cancer prevention behaviors and decisions. Norm fulfillment, the extent to which an individual conforms to societal or cultural norms regarding cervical cancer prevention and screening practices. Perception vulnerability, individuals' perception of their susceptibility to developing cervical cancer based on personal characteristics, behavior, or family history. Perception severity, individuals' perception of the seriousness or severity of cervical cancer, including its potential consequences and impact on health and well being. Motivation strength, the degree of internal drive or incentive to engage in cervical cancer prevention behaviors, such as the desire to maintain good health or avoid illness. Motivation, willingness, readiness, or openness to participate in cervical cancer prevention activities, such as attending screenings or seeking medical advice. Social support, emotionality, emotional support received from families, friend, or other social networks regarding cervical cancer prevention, screening, or treatment. Social support appreciation, recognition or gratitude for the assistance, encouragement, or resources provided by social networks in relation to cervical cancer prevention and care. Social support instrumental, tangible assistance or practical support received from social networks to facilitate cervical cancer prevention behaviors or access to healthcare services. Empowerment knowledge, possessions of information, awareness, or understanding about cervical cancer risk factors, prevention strategies, and available resources. Empowerment abilities, skills, capabilities, or self efficacy to engage in cervical cancer prevention behaviors, such as self screening techniques or communication with healthcare providers. Empowerment desires, aspirations, goals, or preferences related to cervical cancer prevention, screening, or treatment outcomes, reflecting individual priorities and values. So, these are the parameters related to cervical cancer. Now, let us enter the value from the test cases. So, here I have entered all the values from the test cases. Now, click on Submit button. So here we can see the result, that is cervical detected. So here the person is suffering with cervical cancer and it is important that the person seeks a doctor. Now click on try again. Now click on cervical cancer link. Now let us enter another set of parameters from the test cases again. So I'm entering the values from the test cases. So here, these are the test cases which I have shown you during the explanation of the code folder. So from here, I'm entering the values. So here I have entered under set of parameters. Behavior sexual risk is 10, behavior eating 12, behavior personal hygiene 11, intention aggregation 10, intention commitment 15, attitude consistency 7, attitude spontaneity 8, norm significant person 3, norm fulfillment 3, perception vulnerability 3, perception severity 2, motivation strength 13, motivation willingness 11, social support emotionality 10, social support appreciation 7, social support instrumental 12, empowerment knowledge 12, empowerment abilities 12, empowerment desires 12. So I've entered all these values from the test cases which are present in the code folder. Now click on submit button. So here we can see the result, that is you are safe. It means that the person is not suffering with the cervical cancer. Now click on try again. Now click on cervical cancer. So in this way, we can enter the parameters and see whether the person is suffering with the cervical cancer or not. We can enter more test cases from the data and check whether the person is suffering with the cervical cancer or not. Now let us do the prediction for the colon cancer. So click on it. So here we need to upload the images, and after uploading the images, the application will predict whether the person is suffering with the colon cancer or not. Now click on choose file to select the images. So here from the test cases, I'm selecting the first image. Now click on open. So here we can see that the image is uploaded. Now click on upload button. So here this is the uploaded image. So here we can see this is the uploaded image. And here we can see the result for the uploaded image, that is colon ACA detected. That is colon adenocarcinoma is detected. Now let us upload some more images. Click on try again. Click on choose file. Let us upload some more images. So here from the test cases, I'm selecting this image. Now click on open. So here we can see that the image is uploaded. Now click on upload button. So here this is the uploaded image and we can see the result, that is colon ACA detected. That is colon adenocarcinoma is detected. Now let us upload some more images. Click on try again. Now click on colon cancer link here. So here from the colon ACA folder, I'm selecting this image. Now click on open. So here we can see that the image is uploaded. Now click on upload button. So here this is the uploaded image and here we can see the result, that is colon ACA detected. That is colon adenocarcinoma is detected. In this way, just by uploading the images, we can predict whether the person is suffering with colon cancer or not. Now click on logout link here. In this project, we developed a system to predict lung, breast, prostate, cervical, and colon cancers using convolutional neural network CNN and long short term memory LSTM algorithms. Accurate prediction of these cancers is crucial for early diagnosis and improved treatment outcomes. Our system leverages the strengths of CNNs and LSTMs to provide reliable predictions, aiding healthcare professionals in making timely and informed decisions, thereby enhancing patient care and survival rates.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.